Welcome to Learn Mathematics with Moni. Get your books and pen and get ready to learn.
This is the class on bearings and distances. Bearing is the description of a position in relation to another position. Bearings generally is reading the angle clockwise and from the north. This is the four cardinal points: north, south, west, east. Under bearing, we take readings clockwise. That is from the north pole. That is how we take readings in bearing. Another thing is that under bearing, the angles are always described as 3 digits, which means angles range from 000 degrees up till 360 degrees, which means when I want to describe 45 degrees, I won't just say 45 degrees, I'm going to say 045 degrees. This is how we describe in bearing. To explain what I mean by the description of a position with relation to another, I will be describing 3 towns A, B, C. This is town A, this is town B, and this is town C. To describe town A and town C and town B, I have drawn a line. Reading the angle from the north pole of my town A up to the line to the west, to the east, that is 90 degrees. Reading it up to this point, I can say I have about 135 degrees as the bearing of town B from town A. The bearing of town B from town A is 135 degrees, which means I have to turn 135 degrees from the north pole at town A for me to be on a straight line with town B. This is what we call bearing. We have another town C. Having this straight line to town A, I can say, don't mind my line, it is not so straight. I can say that this is the bearing of town C from town A. This is more than 180. The first quadrant is 90. The second quadrant is 90. The third quadrant is also 90. And town C is somewhere inside that third quadrant. That's more than 180. Remember, we are reading from the north pole clockwise. So I can call this as, let me call it a point of about 240 degrees. So I can say town C is on bearing 240 degrees from town C, from town A. Town C is 240 degrees from town A. So this is what we mean by bearing. We can also compare the bearing of town A from town B. If we have to read the bearing of town A from town B, we have to start from the north pole at B. This is 90, 90 making 180, another 90 making 270, and on the fourth quadrant is where we find town A from town B. Let us just call, which means this is more than 270 degrees. I want to call it 305 degrees or 300 degrees. Let's call it 300 degrees. So I can say that the bearing of town A from town B is 300 degrees. The same thing we can do with town A from town C. From town C, reading from the north cardinal at town C, we can see that town A is in the first quadrant, less than 90 degrees. Let me call it 50 degrees. So, describing these bearings this is what we call bearing. I will write the bearing of town B from A is 135 degrees. The bearing of town C from A is 240 degrees. The bearing of town A from B is what we are seeing here, is 300 degrees. And the bearing of town A from C, the bearing of town A from C is what we are seeing here, less than 90 degrees, which is 050 degrees. Remember, I said bearings are always written in 3 digits. So describing a position in relation to another position is what we call bearing. Distances is just the length between 2 points. Like we know, the length between A and B is the distance between A and B. The length between A and C is the distance between A and C. For this introductory level and for junior school students, we are going to take some examples related to this level. A town Y is on bearing 109 degrees from a town X. Let us interpret that. This is a town X, and there is a town Y that is on bearing 109 degrees from it. This is 90 degrees. You know, for bearing, we read our angles clockwisely from the north. So from the north, this is 90 degrees. Taking 109 degrees is somewhere in the second quadrant. So I want to take this as my 109 degrees. So this is town Y. This is my town Y, which is on bearing 109 degrees. We are told that the distance between town X and Y on that bearing is 15 kilometers, which means the length between these 2 points is 15 kilometers. So the first question we have there is for us to find the bearing, the distance of town Y towards the south of town X. This is the south of town X. We want to find this distance. That is the first thing. The second, let me call that question A. Let me call it A. And the second question is for us to find the distance of town Y towards the east of town X. This is the east of town X. So I want to call this B. These are the 2 questions we are asked. Now there is a right angled triangle created here. Looking at from north to south cardinal here, we know that the distance between the north and the south is a straight line, which is 180 degrees. This bearing is already on 109 degrees. So we expect that the remaining angle at this vertex here is going to be 180 degrees minus 109 degrees, which is 71 degrees. So the angle at this vertex X here is 71 degrees. Of course, we can also know this angle here, the third angle here, if there is need for it. We know that the sum of angles in a triangle is 180 degrees. So that 180 minus 90 will give us 90. That 90 minus 71 is going to give us 19. So this is 19 degrees. I don't know if we are going to use it, but at least we have the 3 angles in that triangle. Now we want to know this distance A, which is towards the south of town X. Considering angle 71, A is the adjacent of angle 71. 15 kilometer is the hypotenuse, and B is the opposite of angle 71. If I want to consider this angle 19 degrees I have here, A is the opposite of 19 degrees and B is the adjacent of 19 degrees. That gives me more freedom. I can look for A as the adjacent of angle 71. I can also look for A as the opposite of angle 19. Let us find this out. So I want to look for A as the adjacent of angle 71. As the adjacent of angle 71. I only moved the Y here. I didn't change anything. So let us look for it. Adjacent and hypotenuse are represented in the trigonometric ratio CAR. CAR says cos of 71 degrees is equal to the adjacent, which is A of 71 degrees, and hypotenuse, which is 15 kilometers. This is cos 71 over 1. For us to simplify this, we take a cross multiplication. 1 times A equals to 15 cos 71 degrees. That means A is equals to 15 cos 71 degrees. If you are making use of your scientific calculator or your trigonometric tables in your 4-figure table, we have you get cos 71 as 0.3256, and that means 15 times 0.3256. On multiplication, 15 times 0.3256, you get 4.884. A is 4.884 meters. If I'm going to be taking this to the nearest meters, I will say A is approximately 5 meters. And that is the distance of town Y towards the south of town X. The second question is asking us to find the distance of town Y towards the east of town X. That is the B part of the question. Towards the east of town X, that is looking at this. I can take B as the opposite of angle 71 because it actually is the opposite. And the trigonometric ratio that combines opposites and hypotenuse, this is opposite, this is adjacent. Opposite with hypotenuse is sine. Sine is captured in SO, where sine 71 degrees is equal to opposite, which is B, over hypotenuse, which is 15 kilometers. To solve for B here, we take cross multiplication, where 1 times B equals to 15 sine 71 degrees. Therefore, B equals to, whether you are using scientific calculator or your trigonometric table, you're going to be getting sine 71 as 0.9455. This is 15 times 0.9455. By the time we simplify that, 15 times 0.9 times 0.9455, I get 14.1825. 1825 meters. If we are to take this to the nearest meter, this is going to be approximately 14 meters. That is the distance of town B towards the east of town X. 14 meters. And these and similar cases are the simple questions you will find on introductory level of bearings and distances. If you are a senior school student, check my list of videos on YouTube for you to find higher cases you can find on bearings and distances in senior school mathematics.
Thank you for learning mathematics with Moni today. Do you know you are free to share my videos with your classmates, your colleagues, your friends, your cousins? Do that right now and be a blessing to them and to me.